Assalamualaikum and hello everyone. Welcome to the new video for the new chapter 4, chemical bonding. This video we're going to learn about 4.1 Lewis structure. Okay, and specifically the learning outcome that we're going to learn for this video is to state the octet rule, describe how the atoms achieve stability by attaining stable configuration of noble gas, pseudo noble gas, and half-filled orbital. Okay, but then before we're going to learn more about Lewis structure, first what we have to know is how to draw the Lewis symbol. Because later on, when we're going to draw for the next learning outcome, which is about ionic bond, covalent bond, and additive bond, we're going to use our Lewis symbol. Okay, so first thing first, before we're going to dive into chapter 4, first we're going to learn about the Lewis symbol itself. So, Lewis symbol is a symbol to represent atoms or molecule by showing valence electrons only. Again, valence electron is the outermost electron. Usually, what I always mention to you, yang highest end kita lah. So, highest end. I'm just gonna zoom in. Highest end. Okay, which is our valence electron itself. Okay, so here I have the atoms actually for the period 2 element. I have my lithium until my neon. Okay, so let us look for the Lewis symbol for all of the element in this period. Okay, so for the electronic configuration, yang ini, back to our 2.3 on how to write down electronic configuration. Again, what we're going to start with 1s, 2s, and 2p. Okay, mostly in period 2, sebenarnya sampai which is n equal to 2, the maximum is 2p. Okay, so I have written down beforehand the electronic configuration. So this one I don't think so I have to explain how to write it down. Okay, so that is for the electronic configuration. Okay, valence electron. Okay, valence electron is the outermost electron kita, which is our highest end. Okay, so dalam case ni, for the lithium, as we can see, the highest end is n equal to 2. How many electron? Here we only have only 1 electron. Okay, for the beryllium, okay, so because it's 4Be, dalam 1s2, 2s2. Okay, so the valence electron dia, again, highest end, n equal to 2, adalah 2s. 2. So the valence electron is 2. Okay, next is boron. Okay, boron, again, highest end kita is 2. But now we have 2s2, 2p1. Okay, but then for the valence electron, highest end kita ada pada n equal to 2, then 2s2, then 2p1. Okay, again, reminder back. Based upon our chapter 3, kalau valence electron, for the valence electron, for the s block, we calculate only the electron on the s orbital itself lah. Kalau valence electron, kalau last kali kita isi p orbital, which is, it is a p block, for the valence tu kita kena kirakan pada s plus dengan p. Okay, so dekat sini, valence electron, again, last orbital we fill is p orbital, so we know that is p block. For the valence, kita kena kira s sama p. So s plus p ni, we have 3. So this is for boron. So carbon, here we have yang 2 plus 2 ni. Again, because this is n equal to 2, ada 2s dengan 2p. Okay, next kita tengok, last kita isikan p orbital kan. So p block, mau tahu valence dia, kena kira S sama P. So sini 4. So kalau nitrogen ada 5. Kalau oksigen 6. Fluorine 7. Okay, again yang ini, saya jenis mau ingatkan, bila kita isi the last orbital that we fill is actually p orbital kan. So we know that is p block. To know the valence is S plus P lah. So 2 plus 6. So the valence electron is 8. Okay, so that is the valence electron. Okay, so kenapa it's very important to know the valence electron ni, barulah kita boleh draw our Lewis symbol. Sebab again, it's a symbol to represent atoms of molecule by showing the valence electron only. Okay, so how to draw it? Okay, first, for the Lewis symbol, kita akan draw the symbol of the atom itself. So, contohnya dekat sini, lithium memang symbol dia adalah Li. Okay, so how many valence electron we have is only 1. Okay, so sebenarnya Lewis symbol ni ataupun sebenarnya the Lewis dot symbol ni, you're gonna use the electron tu by using dot. Okay, whereas in previous chapter kita selalu guna macam contohnya 1s, kita selalu guna this type of arrow kan. Tapi di sini kita akan guna dot symbol. Okay, so sini Li ada satu je valence, so satu sajalah dot kita. Okay, so that is for lithium. Okay, next is actually for our beryllium. Okay, so I'm just gonna go back here. Okay, beryllium ni kita ada 2. So we have 2. Okay, so contohnya kalau in terms of memang atomic orbital, kita guna 2s2 macam ni kan. Tapi for the Lewis symbol itself, kita kalau boleh, sama juga kita mahu dia isi 1 by 1 dulu. Cukup dulu. Okay, so sini, so contohnya beryllium ni, mana-mana pun boleh lah. Miss mau buat on the right and on the left. Okay, so ni betul. Kalau kamu buat beryllium, dot di tempat yang sama, salah. Sama juga macam mana kalau apa-apa pun sebelum kita nak partner, make sure kita kena single dululah. Make sure kita single baru boleh partner. Okay, so macam tu lah. Kita nak make sure all of it must ada 1 electron dulu. Maksimumnya ada 4 lah. So sini kira boleh kiri, kanan, atas, bawah. Okay, so kita tengok for boron. Okay, so kita tengok balik pada boron. Boron ni, kita tengok boron ada, we have 3 electron. So 1, 2, atas ke bawah ke? Miss buat bawah lah. So 3. Make sure ini betul. Kalau nak buat kalau mau buat boron macam ni pun boleh juga. Make sure dia sorang-sorang dululah. Tidak boleh terus dia buat partner. Ataupun terus B ni ada 3 ni, tidak diterima lah. Kena dia satu-satu dulu. Okay, next is our carbon. Okay, carbon kita, we have 4 electron. Okay, so gamlah kiri, betul lah, kiri, kanan, atas, bawah. Okay, so this is the symbol dia lah, ada 4. Okay, nitrogen ada 5. So how about it? So kita buatlah N kita. Okay, and then remember must be single dulu kan. 1, 2, 3, 4. Okay, so how about the 5th electron? 5th electron tu di mana-mana pun boleh. Di atas boleh, di bawah boleh, di kanan boleh, di kiri pun boleh. Mana-mana lah. Tapi Miss suka afdol dengan kanan dulu lah. Okay, so kita tengok we have 1, 2, 3, 4, 5. 5 valence electron. Okay, so kalau oksigen ada 6. So again, before anything, make sure dia single dulu. 1, 2, 3, 4, 5, 6. So 5, 6. Okay, nampak ni. So 1, 2, kita kiranya isi 1, 2, 3, 4. Lepas tu lagi 2 tu isi mana-mana pun boleh lah. Make sure maksimum boleh isi di satu bahagian tu, di kanan ke, di kiri ke, atas ke bawah, must be 2 electron lah. Okay, so yang ini. So kalau nitrogen, fluorine, yang ini lagi juga fluorine, kita ada 7. Again, before anything, for the Lewis dot symbol, what you have to know is the electronic configuration first. Given the number of proton, you have to write down the electronic configuration. Then you have to know how much is the valence electron lah. Again, if the atom is in S block ataupun the last orbital we fill is S, so maknanya valence dia hanya pada S orbital sahaja. But if the last orbital that we fill in is P block, so for the valence tu kita kena campurkan S sama P. Make sure yang N yang sama lah. Yang N equal to 2. Kalau 2P tu maksudnya kita kena tambahkan yang 2P tambah 2S. Okay, so that is the Lewis dot symbol. Okay, so let us look for the examples itself. So dia kata write the Lewis dot symbol for the following species. Okay, so this species A, this is the electronic configuration. First kita tengok the valence electron, which is our highest N. Highest N-nya di mana? Highest N kita di sini, 3s1. So valence dia ada berapa? Di sini valence dia hanya ada 1. So how to write down the symbol? So A. Lepas tu kita draw lah satu dot. Okay. Next is element D ni, atom D ni. Okay, so again, before anything, check the electron from the electronic configuration, determine the valence electron tu macam mana, highest n. Okay, so highest n dia n equal to 2. Last kita isi p orbital kan. Okay, so for the valence, kita kena S campur dengan P. So, bila kita tambahkan dua-dua ni, maksudnya from here, kita kena includekan 2 sama 3. Okay, so maknanya we have 5 valence electron. So, valence electron dia 5. So, again, symbol. Then, we're gonna draw the electrons. Okay, so for E, elemen E ni, again, for the electronic configuration sudah ada. So, for the valence electron, check the highest n. Here for S2, so here we have 2. So, elemen E ni, again, symbol dulu. Then the electron lah, 1, 2. Okay, so for G dengan H ni, kita buat sama-sama. Again, the same type of stuff. Tapi yang ini mesti tak perlu explain lah kan. If you be unsure, tengok balik pada time example 1, 2, 3. Okay, so that is how you draw the Lewis dot symbol. Okay, again. Okay, sebenarnya yang ini H sebenarnya boleh jadi hydrogen kan. Betul kalau tak nak hydrogen lah, J lah buat J. So, kita betulkan ni adalah elemen J. So, ni semua sepadan balik. This is, we want it to be J. Sekarang H kan takut jadi confused pula. H for hydrogen. So, that is how we write down the Lewis dot symbol. So, ni kiranya the basis of our chapter 4 lah. Okay, so next baru kita boleh start to our learning outcome, which is to state the octet rule. Okay, octet rule is the tendency of an atom to achieve noble gas configuration with 8 electron in its valence shell. So, kalau boleh sebenarnya elektron ni mau capai 8 elektron di last kali dia lah. The highest n tu dia mau capai 8. Okay, so kalau 8, sebenarnya for the electronic configuration dia akan capai yang NS2 NP6 lah. Okay, because here 2 plus 6 we have our 8 electron. Okay, so there are 3 ways to achieve a noble gas electronic configuration. Either we lose dia. Kalau atom tu lose electron, dia akan form cation, positive ion kita. Dia boleh gain electron to form our anion to achieve octet, ataupun dia boleh juga share electron. Okay, so right now what we're going to learn is actually 3 types of stable configuration. Okay, so first is noble gas configuration, second is pseudo noble gas configuration, and C is the half-filled orbital. Okay, so let us look first for the A is the noble gas configuration. Here it mentioned that the element transfer the valence electron to form ion with noble gas configuration, where the valence electronic configuration is NS2 and P6. Okay, we're gonna start with our sodium. Sodium ni proton dia 11. Okay, tapi elektron dia pun 11 jugalah, since it's a neutral atom. So, elektron dia pun 11 juga. So, I'm gonna write down the electronic configuration. So, this is the electron. This is the electron for sodium, a neutral sodium atom. For sodium plus Na plus, okay, the number of proton is still 11. Tapi right now, plus ni maksudnya dia sudah donate. Sebab dia kan positif kan, maknanya dia baik lah. Dia donate, dia apa ni, terma dia punya elektron. So sebenarnya elektron dia dah kurang sebanyak 1. Okay, so the electronic configuration is not the same as this one. Dah tak sama dah. Dia sudah jadi. So as we can see here, the electronic configuration, the valence one, valence tu yang highest n kita. Highest n kita is NS2 NP6. Sinilah juga NS2 NP6, this one. Okay, so this is how our atom achieve the noble gas configuration. So kiranya kalau case ni sodium dia donate 1 lah. Okay, so contohnya if I want to use another example, I have 12 mg. So the number of proton dia is 12. Number of electron dia pun 12, since it's a neutral atom. Okay, so gonna write down the electronic configuration. So, but then sekarang ni dia belum capai octet lagi. Okay, so macam mana nak capai octet? Again, from here, sebenarnya Miss suka ajar yang how we write down the electronic configuration based on our secondary school lah. Okay, so when n equal to 1, kita ada 2 elektron. So maknanya first shell 2 elektron je. N equal to 2, we have 2s2, 2p6, we have 8. And then 3s2 ni, okay, the highest n ni we have 2. So from here kita tahu dia tak capai octet lagi kan? Octet mau 8. Okay, so from here we know that for this one, this atom ada 12 mg, tapi dia akan jadi dia mau donate 2 of the electron, dia mg2 plus lah. Okay, so for the electronic configuration dia akan jadi, okay, remember the number of electron dia is actually ini lupa pula tulis lah. Elektron dia bukan lagi 11, tapi dia sudah donate 2 of the electron. Originally 12, dia sini 10. So that's why I get 1s2, 2s2, 2p6. Okay, again, this is my valence 1. Yang ni lah, ns2, np6, our noble gas configuration. 2s2, 2p6, 2s2, 2p6. Okay, so that is for the noble gas configuration. Okay, next kita akan tengok adalah pseudo noble gas. Pseudo ni, ayat dia macam pseudo, dia macam fake lah nak katanya. Dia macam it's not true. So ayat jahat dia fake. Yang ni acah je Miss. Ni acah. Pseudo. Dia macam noble gas tapi dia bukan noble. So acah je lah dia ni. So here the electronic configuration is not the configuration of the noble gas. So bukanlah, kalau noble gas kan sepatutnya ns2 np6. But for the pseudo noble gas dia jadi ns2 np6 nd10. So maknanya d orbital tu dia kena fully fill, kena betul-betul 10. Okay. Okay, right now tolong betulkan tidak mau titanium, mau gallium, 31 gallium. Okay, so let us write down the electronic configuration. So we're gonna start with, okay, right now we only have 18. From here we got 18, but we want 31 kan? Okay, so after 3p we're gonna fill in 4s, baru fill in 3d. Okay, but then sekarang ni all of this baru 30. So what should we fill in after that? Okay, after s sudah fill d, we're gonna go back to 4p. So for this one, so this is the electronic configuration of gallium. Tapi kalau kita mau buat dia punya ion, is actually it will be easier for you to rearrange it in terms of n dia lah. Maksudnya ikut order, n equal to 1 dulu, baru n equal to 2, n equal to 3, baru n equal to 4. Okay, what do I mean by that? Here we got 3s2, 3p6 kan di sini. Lepas tu tiba 4s2 sini, balik 3d, lepas tu 4p1. Peningnya. Okay, so we're gonna write it down again. But then in terms of n, so n equal to 1 dengan n equal to 2, no problem lah. Okay, so n equal to 3, we have 3s, 3p, and 3d. So we're gonna write down all of it. Okay, and then last but not least, we have 4s2, 4p1. Okay. So from here again, what we have seen is, here we want for the pseudo noble gas is ns2, np6, nd10. Okay, this one sebenarnya di sini. Okay, so how we gonna remove these 3 electrons? So maknanya our gallium must donated 3 of this. So we're gonna write down gallium ni 31 gallium 3 plus. Okay, so maknanya we're going to donate all of this, so that sebab for the pseudo noble gas, the highest n tu, the valence electronic configuration, kita mau yang ini. Kalau kita buang satu saja di sini, nanti ada 4s tu tidak mau. You want this one, pseudo noble gas. So I'm going to write down again. So we have donated 3, so dia tinggal 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So again, this is what we call 3s2, 3p6, 3d10 is the pseudo noble gas. Okay, dia pseudo, dia macam fake. Dia acah je ni miss. Macam tu lah. Okay, so that is for the pseudo noble gas configuration. Okay. Next is the last one we're going to see for this video is the half-filled orbital. Okay, so all of the orbitals are filled with 1 electron each. Yang ini nanti kita kalau nampak in terms of orbital lah. Tapi yang ini senang. Again, we're going to write down the electronic configuration dulu. So, sama juga for a neutral one, maknanya elektron dia sama lah kan. Okay, so the electronic configuration would be, again, bila kita mau remove the ion ni ataupun remove the electron to form our ion, it will be easier for us to rearrange lah. Walaupun ini sebenarnya diterima kalau kamu jawab, boleh juga. Tapi sebab kita mau remove dia kan, senang arrange it in terms of our N lah. Okay. So we have 3d5 for S2. So when we remove the 2 plus electron, we're going to remove from the highest N kita. So from here lah, we're going to remove here. So, yang ini yang kita tidak mahu. So, we're gonna write down balik. So, 3d5 ni, kalau in terms of here, we can't see it. Tapi kalau kita lukis orbital dia, kita akan nampak dia macam ni. 1, 2. Kalau orbital D, kita ada 5. So, we have, I'm just gonna label the 3D. 3d5. So, again, we're gonna fill in singly first lah. 1, 2, 3, 4, 5. So that's why for this stability we call it as half-filled orbital. Okay, so that is the 3 types of stability that you have seen. Okay, but mostly we're gonna focus on for the next chapter, for the next part of our subtopic itself. Banyak kita akan tengok noble gas configuration lah. For the pseudo noble gas and half-filled orbital, mostly we're gonna use for the element in D block, our transition element. Okay. So, in this video, what we have learned, paling penting kamu kena tahu how to draw the Lewis dot symbol. Okay, and the type of stability present. Okay, so that's it for this video. See you in the next one.